Environment by Ira, Rion, Dylan, and Irfan. All living things lack the ability to grow freely and need the ability to move freely. Plants, just like us, need space to thrive and grow so they could develop their roots. So, we were wondering, will plants grow the same compared from a crowded environment to an environment that has more space? To create an optimal growth environment, you will need space that allows the roots room to grow freely, no competition, it has to have the ability to drain water, and it needs its fair share. We have been observing in our NFT system that the ones in the front grow better than the ones in the back. The roots room is fuller than the ones in the front than the ones in the back. So our hypothesis was, is it true that in order for plants to grow, they need a certain amount of space to grow without competing for water and nutrients, and it varies upon its environment? Does location in the NFT system affect its growth?
In our experiment, we used plastic cups to hold the plant in the water. We used scissors to clip the plant if it got too long. We used chart paper to organize our data, and we used a graduated cylinder to measure how much water we were adding to each cup. For our procedure, we took 16 clippings from one big basil plant. Then we took 3 cups and filled them up with 200 milliliters of water. 1 cup had 1 basil leaf clipping, 1 cup had 5 basil leaf clippings, and 1 cup had 10 basil leaf clippings. We added the same amount of nutrient-enriched water to each cup. In our experiment, the water, the cups, the sunlight, and the type of plant all were the same. The only thing that was different was the amount of 2 centimeter basil leaf clippings. This was our variable. An essential part of a plant surviving is the ability of a plant to have water. Each day we observed and recorded our observations. We replenished the amount of water absorbed by the plant. Each day we observed the one with the 1 basil clipping cup absorbed the most water. Why? Shouldn't the cup of more clippings need more water and nutrients? We found that more clippings, the less water needed, and the poorer growth of the plant and roots. In the cups with 5 and 10 clippings, most of the plants rotted. We had been observing that in our NFT hydroponic system, that all the plants that were all planted on the same day did not produce the same results. It was obvious that the plants in the front of the NFT grew bigger, longer roots, and looked healthier than those in the back of the NFT. So we designed this experiment on spacing. We added seedlings of lettuce, all 2 to 3 centimeters tall, all placed on the same day, 2-25-26. One was at the front of the NFT system, one was at the rear, and one was at the middle of the system. One sample had 2 plants and 1 rockwood. The plant in the rear wasn't different than the one in the front because they didn't grow too many roots. The double was doing great because it was in the front. The middle was the smallest because of the kale stealing the water with its massive roots.
The term density in our situation means how much water does the plants drink up. Testing different plants' distances showed that high-density groups rot while optimal densities allow for the best growth. The one that had 10 rotted and fell, while one had survived and fell to the bottom of the cup. This is important to the plant's growth. Plants need enough space to grow and thrive with an environment of space for roots. Does the 10 clipping lack space? Transpiration is the scientific word for how plants breathe and drink. As water leaves the leaves, it pulls fresh water and nutrients up from its roots, like a straw. The lesson is that plants need water just like humans. They need to drink to survive. All of the plants need space, and if they didn't rot and die. 2, the plants grow and roots grow. As greater the cup with one clipping and the basil plant in the NFT with no rock wall. The plant growth was greater in one clipping after 3 weeks and 6 days. Number 4. There was an minimum rotting and 5 and 10 clippings. The outcome of our presentation. The 1 clippings did the best growth because it had no research competition. The 5 clippings, despite the heavy competition, managed to survive. The 10 clippings did the worst because it had so much competition it barely got any water. In conclusion, an optimal growth environment can be created if it has low density. You have to monitor the plant for research competition. You have to make sure that they don't compete for any water, at the proper growth in water, and we realized that some eventually rotted and some died. But this was our experiment for 3 weeks and 6 days.